Okay. Hello, everyone. Welcome to the module. We shall talk about more things today and take this discussion to the next level. So let me change here. Yeah. So we have until now discussed about auto ML, and then we have spoken about teapot. And today within teapot, we are going to talk about multiprocessing, how to make use of all the processors that you have. And then we should also talk about a specific library, which is called as Dask. This is what we're going to do. Suppose that if we have time, we shall get into feature tools, which is yet another AutoML library to perform feature engineering. It performs something called as feature engineering. And once this is done, we will jump into cloud-based machine learning services, in which we are certainly going to talk about SageMaker, Autopilot, and we will understand how to end-to-end build the model, deploy the model in production, and use that model for some predictions. I'll also go one step here. We will also, in Teapot, talk about deployment of the model and post-deployment monitoring. How do you monitor the model? That is also something that we're going to talk about. Then we will get into Azure ML Studio, Google Cloud Platform, AutoML, and then we are going to talk about explainable AI. In the interim, if time permits, I'm also going to talk about Amazon machine learning services. You have a lot of machine learning services such as Amazon Recognition and a bunch of other things. We'll talk when we get into that. Amazon Lex, which is for chatbot building and all that. So let's talk about the parallel processing capabilities now. And first of all, we will look at parallel processing from Python standpoint. Okay, let me zoom this. But even before I zoom it, let me make sure that the runtime environment is GPU. Yes, it is. So let me see. I'm connecting. It's connecting to the required computer. It is initializing now. It is also mounting the Google Drive at the same time. It is still in initializing phase. Let it complete that. Come on. Not sure why it is still in the same state. Yeah, now it is connected. Usually it connects faster. Not sure what happened this time. So, friends, executing one task after another is called as sequential processing. Okay, it's called a sequential processing. But then, if you have multiple processes, and if you feel those can run in parallel, for example, say you have 3 different models. okay, or three different application programming interfaces, APIs. What does an API stand for? Application programming interface. So say there are three APIs. API will help you establish the connection between two systems. For example, you have a database, SQL database, and say you have Python. If you want to establish the connection between these two, SQL database and Python, we use something called as API, Application Programming Interface. The first, say there are three APIs. Say the first one is something which will help you get the data of weather conditions. Weather conditions. And say you have another API which is used to get the data pertaining to stock prices. Stock market, what are the prices? Say you have a third API which will tell you what is the gold rate, gold exchange rate. If you want all these three, and if you want to get the information, and if you're saying that I'll do it sequentially, then it doesn't make sense, right? There is no dependency of one after another. Extracting weather conditions information, getting that data information from a website, and getting information of stock prices from another website, and then getting the gold rate information from another website. These are three different tasks. So you need not run it sequentially. Sequential processing is not preferred. Sequential processing is not preferred. Hence, we resort to something called as parallel processing. Parallel processing. In parallel processing, what do? We ensure that all these three APIs are executed at one go. Okay. Otherwise, what will happen is you'll be underutilizing the CPU cores. On your computer, you'll have something called as cores. Sometimes you might have quad core. Quad core means you'll have 4 different cores. You might also have octa core, means 8 different cores. And on each core, there'll be one processing which will be happening. If you can make use of, if you do not use parallel processing, what will happen is, by default, the system will assume that you want to sequentially execute this. And out of these 4 cores, quad core means 4, octa core means 8. Out of these 4 cores, only 1 core will be utilized. And remaining 3 cores will be sitting idle. Only 1 core will be running and remaining 3 cores will be just sitting idle like that. So what should you do then? You have to resort to something called as parallel processing. If you make use of parallel processing, process 1, which is extracting the weather conditions, would be running on 1 core. Out of these 4, 1 core. Then stock prices, extracting the data, would be executed on another core. Extracting the gold rate would be executed on another code. So it will accomplish the task faster. Say this takes 5 minutes and this task takes another 5 minutes and this task say takes another 5 minutes to accomplish. If you're going to use sequential processing, it will take total 15 minutes. After this is completed, task 1, it will move to task 2, which will also take 5 minutes. And then it will move to task 3, which will also take 5 minutes. So in total, you'll have 15 minutes. That is the amount of time it is going to consume. Instead, if you resort to parallel processing, all these three will start at the same time and more or less end at the same time, right? Then all these three tasks put together would get completed in approximately 5 minutes. Okay, so you're just trying to make use of all the cores which are available with you in an optimal manner. And most of the modern computers have quad cores, means at least 4 cores. And how do we achieve this parallel processing? How do I achieve that? How do I achieve multiprocessing? This can be achieved in Python by using a library called as multiprocessing library. There is a library which is called as multiprocessing. There is also another library which is called as concurrent futures. Concurrent futures. These are the libraries within Python. We can make use of that for multiprocessing. And also, to better understand multiprocessing within Python, you also have a built-in library called time, which is going to capture how much time each step takes. From the previous line to this line, I mean, between two tasks, how much time is it taking? That can be captured. Okay, so let us understand here. There is a code that we are writing. Just to understand parallel processing, friends, there is nothing else that we will be understanding here. Just the parallel processing component of it. You're importing time and you're going to define your own user-defined function. In that user-defined function, you're just giving it a name as sleep underscore function. I mean, you can give any name. Within Python, if you want to write a code which acts in a specific manner, which executes a task in a specific manner, then either you can use inbuilt functions from some library, either you can use inbuilt functions from certain libraries, or you can use user-defined functions. Okay, you might use inbuilt functions or user-defined functions. So here you are writing a function, and then you're saying print sleeping for 1 second. Then you're saying time.sleep of 1, print done. Okay, and then that means what you're saying is you're pausing the time for 1 second, and then you're going to print the next line. Okay, that's what we are doing. And here you're defining a main function, and you're saying run the function 5 times. The sleep underscore function, run it 5 times. And then start time, start counting the time, and then end the time after you run it 5 times. And you're saying from I mean, from the time you stop until the time, I mean, from the time you start until the time you stop, how many seconds did it take? And you're saying round it off to 2 digits and print this is what you're saying. So if I were to simply run this, let's see how much time it takes. It takes 1 second to print. Total, it has taken 5.01 seconds to execute. 5 times. And everything is as expected. Sleep underscore function. And you're saying run it 5 times. Each time it runs, you want to print the statement, sleeping for 1 second. And then done. Now, we are wasting time and the CPU cores by running it sequentially. The results of this function are independently displayed here. It is not that, output of this will go as an input of this. No, it doesn't work that way. So let us resort to some parallel processing capabilities. Even before we go to parallel processing capabilities, you can make this function a little better. Rather than use this function 5 times here, sleep underscore function 5 times. You can just keep a range. You can say run it for 5 times. Range is 5. Let me run it. That's the only change that we have done. And this is just to ensure that it is slightly better way of writing the code. Nothing sacrosanct about it. And here also time took 5.01 seconds because it's all sequential. The only change is here, rather than writing it 5 times, you are writing a single line by creating a for loop. Then you have multiprocessing. You have multiprocessing. From that, you're planning to import process. And then you're saying, here is my sleep function. I want to print sleeping for 1 second. I want to wait for a second and say print done. You're starting the time here. And then you're using this process, which will do multiprocessing. Doing 1, 2, 3, 4, 5, all the sleep function, you want to run 5 times. You want to start each process, and then you want to join them. You want to start and then join all the tasks. So both process and start are self-explanatory. And this join, if you call join, right, it is going to join all the various lines and it's going to count the time at one go. Okay, so let me run it. Let's see the results. Look at that, it has taken only 1 second for 1.04 seconds. Approximately 1 second. Earlier it has taken 5 seconds. So by using this parallel processing capability or parallel multiprocessing library of Python, we could easily achieve this. Okay, there are other different ways of writing also. I mean, I'll just skip this part. Not that relevant at this stage, but I can also run this and quickly show you what's happening. It has taken roughly 2 seconds. Okay, this is just, I mean, we need not worry too much about this, but the point is we have something called as concurrent futures. Concurrent futures is another library which helps you do parallel processing. In this new approach, you also need to use an additional argument called process pool executor. We need not get into the depth of each of this and understand each aspect of it, but we have two things. Uh, at a high level, we'll understand. One is submit. It is used to run the function in parallel. This will help you run the function in parallel. Okay, so PPE is nothing but process pool executor. Dot submit. Then submit is a function which will execute the function in parallel. Then you also have another function called as result. And this is used to obtain the returned value from the function. Whatever function is, whatever value it returns, you take that. Okay, and there is also a different way of running the code. I mean, I'll just, this part I'll certainly skip, not that important. Now let's get into a third library, which is called as Dask. What is Dask? Dask is, I would say, a revolution in the space of parallel processing at scale. What do I mean by processing at scale? Friends, say you built a chatbot, AI-driven chatbot. When you have chatbot, what will happen? People will start using it. Say you built a chatbot to clarify the doubts of students. If there are any doubts, they'll come here, they'll type it, and your chatbot is going to give a reply. For example, they can type, what do you mean by teapot? What are the various hyperparameters within teapot? Whatever questions you ask, you'll get the responses. If people like it, and say you tested it for 100 users. Now, when people start using it, and if they like it, many people will start using it. Say 1,000 people, 10,000 people, right? 100,000 people started using it. Then this chatbot should not crash. It should not so happen that, oh, these many people are concurrently in parallel using chatbot, so system will crash. It should not so happen. Right? So if you want to build applications which can handle this kind of a scale means increasing amount of inputs coming to this chatbot in this example. Or if a lot of people start using, then your system should not crash. So that is about Dask. Right? It will help you process the data at scale. And this Dask library will help you work with NumPy, Pandas, etc. Okay, now also one more thing is there are certain data sets. When you load those data sets into Python, it will throw error. For example, say you have 10 GB data. You have 10 GB data. And then what if you have only 8 GB RAM? Because when you load the data into Python, it gets loaded onto RAM. In this case, it will throw an error. It will say that you have more data than the memory. If it says you have more data than memory, then obviously you'll have error. You'll get some error. This kind of scenario also can be handled by Dask. And what Dask does is, if you have 10 GB data, and if you have 8 GB RAM, it will store 8 GB on the RAM, and remaining 2 GB Okay, remaining 2 GB, it is going to store on your hard disk. Hard drive. Okay, that's how it works. Okay, so Dask will allow you to run code in parallel with minimal changes. So let us first install this Dask. So let me run this and it's going to install Dask. Please remember to mention complete so that the complete file gets executed and installed. Okay, then this is installed. Then some error is coming. That's okay. We will use this function called percentage time, which is considered to be a magical command. And it is used to measure the amount of time needed for this particular code to be accomplished. Okay, how much CPU time does it take? Okay, let me run it and see. So what you're doing here is you're making use of NumPy, and you're saying NumPy dot once. You're saying just generate all one numbers. How many such numbers do you want of this dimension? Meaning 1000 by 1000 by 1000. These many ones you want to generate. And this percentage time is used to measure the time needed for this cell to finish the execution. So you run it. And then you get the CPU time. It has taken total 1.79 seconds. Okay, so you just generated some numbers. Now if I use Dask, Dask has something called as array of numbers. Like NumPy, in NumPy also you have generated array of numbers. Here also if I use the same thing using Dask, let us see how much time does it take. Here it has taken roughly 1.78 seconds. That is a wall time, complete amount of time. Now if you use Dask, if you import Dask array, and then if you say use that and generate these numbers, similar to this, same once. If I were to run it, let's see how much time it takes. Do you know what? It has taken only 174 milliseconds. Just 174 milliseconds, and here it has taken 1.78 seconds. So huge amount of time is getting saved. Now let's look at data frames. Okay, let me show you this on what happens once again. Okay, so now that we have compared how arrays are generated, and if you make use of Dask, because it makes use of parallel processing, look at how fast things are getting completed. 143 milliseconds as opposed to 1.79 seconds. This is with respect to arrays. Comparison between your regular NumPy versus Dask. When you work on real-time projects, ensure that you make use of Dask, and in the interviews, ensure that you talk about this. Because if you're working in real time, obviously, you would be trying to do parallel processing. You'll write the code to perform parallel processing, which is very, very important. And all these things are available on machine learning on cloud. There, all these techniques which Teapot uses, all the techniques which Dask uses, I'll also show you a few feature tools. All the techniques which feature tools use All those things, all these concepts are there on machine learning on cloud. When we go to machine learning on cloud, we don't know all these things. I mean, we'll not learn all these things. It will just give you the output. For you all to understand what is happening behind the scenes in machine learning on cloud, all these concepts are very, very important. So now what we will do is we will take data frame and we will use pandas. We will see how much time pandas takes. And then we will also use Dask. And this time we will make use of some kind of large data set. Okay, and we'll see what happens. So here, as part of this code that you see, what we are doing is we are trying to generate approximately 10 GB of data. And we are giving a path here. We are saying in this folder called teapot auto ML teapot, okay, I want all the files to be stored, generated and stored. Randomly, you're generating some numbers in between 0 to 100. And then you're trying to generate data from 2010 to 2022. So 10 data sets is what we are generating. All these are time series data sets. You have a start time, end time. It's time series data set that we are generating. Time series means it will be in sequence, like day 1, month 1, year. So 1/1/2010. Okay, then you have 1/1, 2/1/2010, so on and so forth. Just give me a quick minute, friends. A quick minute. Extremely sorry. Extremely sorry. Just give me a quick. Okay, sorry. I just passed on details of a few people who are unable to connect to our friend. But yeah, let's proceed further. Then you'll have 3/1/2010. In that way, you'll have data all the way until 31/12/2020. You're just generating some random numbers. Why am I doing that? Just to show you on how much time it takes. So after generating the data, you're storing the data into CSV format. Let me run it. It would certainly take a while because it has to generate that much amount of data, right? And then let us go to this folder and see whether the data is getting generated or not. Let me click on this. Yep, Google Drive is there. Let me open that. I should have actually run this and then I should have taken that quick timeout. But this teapot is showing up here. And this teapot has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 files. It is still saving. But then what we are trying to do is 2010, we have one file, 2012, 2013. In this way, you have 10 years of data, which we are randomly generating. We are using this random, and then we are generating the data. Okay, randomly we are generating data. Now, what I'm going to also show you is that, so I go to just click on this, or let me just hover my mouse on that. It says that this file got created, last modified on June 10th. And the file size is 237.38 MB. So that means it is still generating. Okay. Let it generate the data. While it generates the data, we will go ahead and understand a few other things. And the reason why I am going to generate 10 files, each of size 1 GB. This is of size 1 GB. This is of size another 1 GB, 1 GB, etc. So overall put together, you have 10 GB of data. Okay. Overall, you have 10 GB of data, which got generated. And this is the data size. What if you have your memory or RAM, which is of 8 GB? If you have only 8 GB of data, then what do you do? Okay, it's a $1 million question. So let me now see what is the size of this. Yep, it became 1 GB. This is getting generated now. This got generated long back of 1 GB. So it's taking a while to generate those files. Even if it takes 1-2 minutes each, it will take 10-20 minutes, I believe. So let it run. While it runs, I'm going to walk you guys through the next piece of code. I'm just checking on how much it generated. I can probably stop it. The reason why I've stopped it is because already we have data. So this is how it's going to generate. Okay, so I'll not run it again. If you see this piece of code, then it shows you the list of all the files. No such file. Okay, my bad. I need to take this and depot. Let me copy this. And let's see how many files are there. Okay. Why is it saying no such exist? Oh, my bad. My bad. It is getting split, right? My bad. I don't know how to. Yeah. Sorry about that. But that's okay. That's one another experience in Google Colab. Sometimes certain the way you write it works. So here it didn't work because there's a space, teapot space auto ML. When you have space, you need to put it in single quotes and give a complete path, and then it works. So these are the various files that got generated. Now let's take a look at how much time it takes for pandas to read all of these things into a single file. So you're aggregating the data. We are generating the data for 1/1/2010, 2nd Jan 2010, 3rd Jan 2010, etc. until 31st Jan 2010. Okay, and then you aggregate the data and then you get for Jan 2010. Okay, in that way, if I were to aggregate the data for 1/2/2010, 2/2/2010, 3/2/2010, etc. If you have 28 days, 28/2/2010. If I aggregate it, you get the data for Feb 2010. You're adding the numbers, values in this. In that way, if I add for March, April, May, etc., if I do that, how much time does it take? Let's see. So I'm importing pandas, and the magical time function we are going to use, which will tell us how much time this takes. So let me do it. You're reading the file only 2010. You're taking date as a parse date, and what you're doing is you're saying group by the date, which is every month, and take the sum of that. That's what you're doing and saving this. Now let us see how much time it is going to take. My best bet is it should not take more than a minute, but let us see how much time it takes. Yeah. It has taken approximately what? 31.3 seconds. Wall time means from the time it starts until the time it ends. Then we can also use something called as glob library. And then you can read all of the files individually and you can concatenate them. You can use a function concatenate. Concatenate means combine. Now if you run it, if you run this piece of code, it takes huge amount of time because you have 10 GB. And if you have 8 GB RAM, it will throw error. It will throw error if you have 8 GB. Otherwise, it will take probably each file is taking some 30 seconds. So if you have 10 files, it will take roughly 3 minutes. Let me run it. Just for your attention, I'm running it just for you all to understand on how much time it takes. But be rest assured that it takes more amount of time. Rather, it takes significant amount of time, not even 3 minutes, because it has to parse all those files and combine them, all the files. So let's see if you want to append one file after another, 2010, 2011, 2012, you're just going to append that, and then you're going to group them by doing summation of date and age. And if I just leave it like that, it will take huge amount of time. Let it run. If it runs, it is better for us because we can also look at how much time it's taking, and then we can run it using Dask. The idea is for me to show you all that if you use pandas, it takes huge amount of time, whereas if you take Dask, it gets accomplished just like that. Okay, 10 GB of data, it would probably take 2 to 3 minutes. And even if you have 10 GB data, even if you have 10 GB data, and if you have 8 GB RAM, It will still work. Okay, and let it run. While it runs, I'm going to explain you about something else. Within Dask, you have arrays, which we have already seen. You have data frames, and you have something called as bags. Bags is used to store something called as log files. You have your server logs, okay, and log files usually record each and every activity that you're performing on the server or on your computer. Even on your Windows machine or Macintosh, you have log files, okay, which usually explodes into big size. And if you're trying to process these kind of big files on your regular Python, it will throw error. So instead, what should you do? You have to just export the parallel processing capability, which is nothing but Dask. Okay, so that's how it works. And then you have a few more things that I'm going to talk about as we proceed further. Just give me a quick minute. So it's taking still some more time. I would rather let it. I would rather allow it to run. The reason why I'm going to allow it to run is at least in the next session, and the next session is going to happen from Monday. Saturday and Sundays we do not have session. Again on Monday we will have the session. So it has thrown an error. The reason why it has thrown an error, look at that red. It has thrown an error. It has stopped. Why? Because you have only 8 GB RAM allocated, but your data has 10 GB. So it has thrown error. Now, if I were to use Dask data frame, and if I read all of those files, when I say star means it is teapot. Here it is. Yep. So when you say teapot, that's the path that we're giving. In my drive, teapot auto ML and teapot. And you're saying star.csv, meaning in star you can have any name, .csv. And you're passing it based on date. Then when you group it by date, and when you do summation, and then when you say compute, it is going to load the data without throwing any error. Okay, so this also takes some time, so we'll have to wait and see on how much time it's going to take to execute it. While that happens, I'll scroll down and explain about a few other things. What are a few other things? We will make use of a function called as delayed and compute, which are both part of Dask library, which is actually going to help you perform parallel processing. And then you're installing Dask ML. What is Dask ML? Dask ML, I'm not going to, I'm just saying that delayed and compute can be used to perform this. And then we have something called as Dask ML. This Dask ML performs machine learning activities. So you need to install that. Once you install that, as you can see, it is already installed. And then you need not again install teapot. If teapot is already there, well and good, you need not install it, so I'll remove it. And then you're going to import libraries like teapot classifier, you're loading the digits, training test split, and then you're using Dask distributed environment. When you use Dask distributed environment, then this Dask.distributed is actually a new thing which will make use of Dask cluster. Okay, it makes use of cluster. Cluster is nothing but collection of multiple computers, multiple servers. Okay, it is collection of multiple computers or multiple servers. Now it's saying that you have 4 workers, 4 cores. So it's a single core stuff that you have. And the total memory available is 27.33 if you make use of a Dask cluster. When you just say client, which is part of Dask, it immediately creates a cluster. Okay, then if you click on this link, it will open another window where you can see the progress on how many tasks are running, how many tasks are running in parallel, etc. And here, what are you doing? You're loading the data. You're splitting the data into data, which is inputs, and target, which is output. And you're giving the test size as 50%. So training data will be 50%, test data will be 50%. And you're saying what is the shape of the data? Go to run it. Okay. So maybe I didn't run this to load this specific data set. This is throwing error because we didn't install this or we didn't import this. So let me run this. While this happens, if you see here, friends, when we have tried to use pandas, and when we tried to use pandas to concatenate the data, all the files, it threw us an error because we had 10 GB of data, and on one computer you'll have 8 GB of RAM. So it threw an error. But the moment you use Dask, it took 3 minutes 50 seconds. That's a wall time. End-to-end time is what 3 minutes 50 seconds is what it has taken. But it has accomplished a task for you. Same 10 GB data, when you tried using pandas, it threw an error. But the same 10 GB data, when you use Dask, it is not throwing error. It has actually completed that task. Okay, so you're importing all the required libraries. You're installing Dask ML. Now, if I were to run this, it would not, should not. Okay, so let me also install Teapot, because maybe we installed Teapot in the previous module. Let it install. Okay, then okay, so this is also done. This client is available. Yes. And then when you load the digits, data set, you're splitting the data, 50% training, 50% test. If you say, show me the dimensions of training data and test data, you have the dimensions which are available. Okay. And then you have this Teapot estimator. If you use number of jobs equal to -1, all you're saying is use all the cores. If you have 4 cores here, if you observe, you have 4 cores. So you're saying use all the cores. Then you have random state, use Dask equal to true. By default, it is false. So only if you mention true, it will start using that. Verbosity is 2, and you're saying take not more than 10 minutes and run it. When I've run it previously, it has completed this, run. And you can see the results in the Dask dashboard by clicking on this. You can see the results on how many things were running in parallel, etc. Okay, so that's how you can make use of Dask and parallel processing. And if you give 10 minutes, good enough, it will conclude. So it says that teapot closed prematurely, but maybe instead of 10 minutes, if you increase it to 15 minutes, I think it will give you the complete results. All right, so this is how you make use of parallel processing. Let me quickly once again tell you. When we have used array, when we used NumPy, we experimented three things, friends. When we used array, NumPy took probably 5 seconds in this experiment, but when we use Dask, it has taken maybe 1 second. And then we also tried it on data frame. When we try to generate data, 10 GB data, and when we try to load it using pandas, it threw error. It could not load that. But then if we use Dask data frame, when we used it, it didn't throw any error. And then we have looked at how to use this parallel processing task within machine learning. And for that, what we have done is in teapot, when we have executed teapot classifier, we used a simple argument called useDask equal to true. And that useDask equal to true will try to use all the processes which are available. And it will execute the task faster for you. Okay, that is what it does. Okay, now that we understood all these aspects, I would like to stop here. And when we connect on Monday, we are going to look at teapot deployment and post deployment. How do you monitor the model? Monitor the deployed model. Okay, once again, after this, we'll get into feature tools, so on and so forth. So thank you so much. And on Saturdays and Sundays, we'll not have sessions. But then we also post questions on LinkedIn. On LinkedIn, this poll question is given. I request everyone to answer. This is all about your hyperparameters. Right? And what we also do is, we keep posting a lot of quiz questions, interview questions, right? A lot of people, keep answering the questions because it's not one question. There are a bunch of questions that we keep posting. Bunch of questions. And if you want access, these are all interview questions, by the way. So keep answering these questions whenever you find time so that you improve your interview preparation skills. And a lot of people get placed through us. These are the bunch of people who got placed just in a matter of 2 weeks or so. So all the details will be there on our website also. And they conduct the success story sessions. So please, when you open that, follow our page so that we keep getting these kind of interesting things moving forward. Okay. And please do not forget to subscribe to the YouTube channel. Thank you all so much. And on Monday, we will take this discussion to the next level. Thank you all. Until then.